Welcome to the Personal Brain Trainer Podcast. I'm Dr. Erica Warren.
And I'm Darius Nomdaron, and we're your hosts. Join us on an adventure to translate the scientific jargon and brain research into simple metaphors and stories for everyday life. We explore executive function and learning strategies that help turbocharge the mind.
Come learn how to steer around the invisible barriers so that you can achieve your goals. And this podcast is ideal for parents, educators, and learners of all ages.
This podcast is brought to you by Bullet Map Academy, and we have a free dyslexia screener app called Dyslexia Quiz. It's fun, engaging, and interactive app. Try it now. Just search for Dyslexia Quiz on the App Store and see how your scores differ from your friends and family.
This podcast is brought to you by GoodSensoryLearning.com, where you can find educational and occupational therapy lessons and remedial materials that bring delight to learning. Finally, you can find Dr. Warren's many courses at LearningSpecialistCourses.com. Come check out our newest course on developing executive functions and study strategies.
So, Erica, what are we going to talk about in this podcast?
We are going to be talking about visual processing.
I'm sure if you're a parent with a child with specific learning difficulties, you will have heard the term processing before, but sometimes getting clarity on what people mean by processing, because it's a very broad term. So visual processing. So what's your background in understanding visual processing?
Well, I think I got a really deep understanding of visual processing when I was at the University of Georgia. I was getting my doctorate, and I had an assistantship doing neuropsych testing. So I was often testing college students, some of them for the first time, some of them had been tested before. But there are two types of tests. There are cognitive tests and there are achievement tests. And under the realm of cognitive tests is visual processing. And visual processing is really how you make sense of what you see. Okay. So it's the interpretation of the images that the eyes perceive. And it plays a very key role in learning visual information from our environment. And it's really fundamental to reading, math, and spelling. So although visual processing does impact achievement, it's not considered an area of achievement, meaning academic achievement.
Yes.
It's an area of cognition. So it's really, again, how we're making sense in any kind of processing. And there are many different types of processing. Visual processing isn't the only area of processing. We also have auditory processing. And we're going to be talking about that later. And there are other types of processing. But today we're really going to be focusing specifically on visual processing because although it sounds very simple, it's actually very complex.
So you've got a list here of 9 visual processing, how you can chunk it down into 9 things. Why have you chosen those 9 things?
Well, these were areas within the cognitive testing.
Okay.
That were done when I was doing neuropsych tests. Now, not all people that do testing go into all of these.
Okay.
So it's not required, but from my perspective, it's really, really important to do a deep dive into visual processing because when you look at each of the 9 different ways of processing visual information, they all require a different remedial response.
Okay.
So if you really want to help a kid with visual processing issues, you really need to see what are the specific areas of weakness so that you can address them and build that skill so it's no longer an area of weakness.
And I'm just thinking about other podcast listeners who aren't thinking about remediation of children and remediation in general. I mean, many of our listeners are listening because they're thinking about their own personal brain and training their own brain. I mean, would you say that once you become aware of these 9 things that you're going to share with us, that it develops your own self-awareness and helps you develop your own visual processing abilities and performance?
I think, when you're listening to this, you might say, wow, I think I might have a weakness in visual discrimination.
Can you use other forms of your visual processing to compensate for areas, your weaknesses? Can you, so I'm looking, these are questions that I've got in my brain. So can you tell us like what the 9 are that we're going to talk about and we get stuck into them?
Yeah, but I want to answer your question first because that was really interesting. How do we compensate for a visual processing deficit? And I'd have to think about that. I don't really think that you could compensate with another visual processing area because they're different. But what you can do is you can compensate with auditory processing.
Ah,
So, for
interesting.
example, if you're having a difficult time processing visual information, you could use your inner voice to help you, or
Yeah.
other areas of cognition
Ah,
or
yes,
spatial skills.
yes.
So it's interesting. So I wanted to just deep dive into
Right.
that for a moment before we go into the 9 different ways of processing visual information. Let me give a quick overview.
Okay.
There's visual discrimination, visual directionality, which is very similar, and we'll get into that, visual memory, visual sequencing, visual closure, visual reasoning, visual synthesis, visual spatial, and visual figure ground.
Okay. They are all a mystery to me right now, and I'm looking forward to this mystery being revealed.
All right, so let's jump into number 1, visual discrimination.
Okay.
That's the ability to tell the difference between images that are similar, but not the same.
Oh, is that like the spot the difference pictures you had when you were kids?
I don't know what those are. What are those?
Oh, I used to love them. So you get this picture of like a man with a dog walking down a street with a house behind him, and it would be like a line drawing. And then you'd have exactly the same picture, but there would be like 6 or 8 little things removed, and you'd have to spot what those 6 or 8 things that are slightly different are.
Yeah, that requires some visual discrimination. It requires some other types of visual processing as well. But
Okay.
a really good example of visual discrimination would be being able to tell the difference, for example, with a P and a B.
Oh, I
They look
see.
very similar.
Okay.
They're made up of the same components, but they're in different places.
They're in different positions, different orientations.
Right,
So, okay.
right. So, some symbols look very similar. The number 5 and the letter S
Yes.
are really, really similar. And can
Yes.
you discriminate between them? Now, there's some things that have much more subtle differences. And let's try to think of some examples. What are some things that look very similar but are completely different?
W and M.
Yeah. And now you're getting into something which is more of that, which is visual discrimination, but also fits under visual directionality.
Oh,
So
yeah.
one
Okay.
is going up and one is going down.
Yes.
Notice that when I said visual discrimination, I picked a P and a B. Now,
One's
B,
going up and one's going down.
right. Visual directionality would be more of an example of a B
Oh,
and a D.
okay. Right. I've got you. I see.
So
All right.
visual directionality is the second one. So
Yes.
visual discrimination is, now I separated them because there are times when like an S and a 5, we didn't change direction. There
No.
was some other subtle difference in discriminating between the two.
Yes. One has a bit of a sharp angle on it, and the S has the nice curve. I've got you. Right. So
So
that's
direction,
discrimination.
and the directionality gets into being able to discriminate between left and right, and
Okay.
objects facing left or right. And you
Okay.
could even talk about east or west, or north and south, or up and down as well, has to do with directionality. So it's
Yes.
a change in direction. And that's what's so interesting, is because you look at a B, a D, a P, and a Q, and it's the exact same shape. It's just a change in orientation. So you can see for some kids, they're like, wait a minute, that's all the same thing. Particularly when you have, like dyslexics have, an outstanding visual spatial ability. So they're really good at visual spatial skills. So the first thing that they're going to notice is, oh, that's the same thing.
Yes. Because in their mind, they're not just looking at a B, they're thinking about it in all sorts of different angles and rotations, and they're looking at it in a three-dimensional, whereas someone else might just look at it flat B, that's the way it is, end of story. And they see something that is a Q and it looks completely different. It's different, you know? But
Right.
yeah, I get you.
So it's kind of interesting in a way, an extraordinary strength of many dyslexics becomes a deficit because they're so good at that ability to move things in space that they don't see the difference between it. And that confuses them. So you could see how that there's a subtle difference between the discrimination and directionality, which is something that I really like to bring out. But, it's not just with letters and numbers. It can be with symbols like the greater sign and lesser sign. Oh my gosh, that killed me when I was little. I was like, oh my gosh.
It took me so long to try and figure that out.
Yeah. Well, and of course, I wish I'd had me when I was little, because as soon as you turn it into a Pac-Man and you say that it eats the bigger number, then it's easy.
Oh, okay. It eats the bigger number. Oh, I see it.
Right. Or some people turn it into an alligator but you could turn it into for example, you could turn it into an arrow, in which case the arrow is pointing to the smaller number. But it's interesting. I think, when you turn it into something and you have a story behind it, then there's a perfect example of a compensatory strategy.
Yes. So you put it into some sort of context. So it's like it gets anchored, it gets locked into a context.
A context, a story.
Yes.
And that's a perfect example of a compensatory strategy. So we'll try to weave those into this, if you can help me remember as we go through these. And for directionality, helping kids to understand their left and their right and coming up with strategies, whether they notice if you put your hands out in front of your face, your left hand makes an L, your right hand doesn't, but it's a backwards L. So for some kids, that doesn't really work.
Yes.
But you can put a ring on your left finger. You can do different things. But I know that, even in a stressed out situation, if someone's like, take a left, they're often saying your other left.
Yes. That's right.
If I'm in that kind of stress moment, and I can actually still reverse my left and right.
I did a podcast with someone who was talking about their driving test. And in the UK, you're allowed to tell your driving instructor that you're dyslexic. And they will, how in a driving test, often they say, take a left, the next left, or the second left. Well, they're then obliged to put their hand out and point which direction is while they say it. So you've got these double, you're saying left and the guy's pointing left, or right and the guy's pointing right. And also, they often put a colored band on their left thumb, etc. And I know with sailing, I'm a sailor, and port and starboard is so important in sailing. If you're on starboard tack, you have right of way. If you're on port tack, you don't. And that's a big deal when you're racing. And so if you've got difficulty with your left and right, I then have to translate left into port and starboard. And so you can't just say left. You have to say port or starboard, because that's what everyone else says. And you're like, oh my goodness, why can't I just say left and right? And so I have to do a double shift. I have to put my hand up to do the L to figure out what left is. And then I have to say left has 4 letters and port has 4 letters. So that side is port. And this is all happening instantly while I'm in the middle of a race or whatever. But then it gets more complicated, because it's like, I need to be on starboard. Am I on starboard? Right. Left is port. So I'm not on left, so I'm on right, and so on. So you've got 3 layers of decoding to get to the actual results, which, because I'm not automatic, which a lot of people in sailing solve by putting a red dot and a green dot on the boom of their boat. So if they see the red dot, they know it's starboard. If they see the green dot, they know they're on port. So they're not even having to do all of that processing. So many people that are into sailing are dyslexic, actually, because it takes a certain skill set, three-dimensional dynamic kind of skill set, to become really good at it. That's my theory anyway. So yeah, left and right.
So there are, and I have PDF downloads that offer activities for kids to do or adults to do to help to strengthen these areas. So I have workbooks for each of the different areas.
They are really good. Actually, I saw a few of them a year or so back, and I started doing them. They are clever as anything, Erica. I mean, and they're so fun. And you can see as a teacher starting, oh, that's what she's doing. Oh, that's very clever. And even some of you've got a workbook I remember doing, and I may be going off topic here, but it might relate to it. It's like, when they do these tricky tests, which are, choose something that is not an apple, or choose something that is bigger than an apple, and it's all this bigger than, small than, not this, is this, isn't that, and so on. All that kind of language. I suppose we're going off topic a little bit here, but does it relate to anything that you're talking about here?
A little bit. You're talking about, I have a series called Following Directions, the Fun and Easy Way.
Yes.
And although it's focusing on following directions, language skills, there is a visual component.
Yes.
There's a visual component because it's a grid of objects or animals, and it could be a maze that you're going through, or it could be process of elimination, or you may be drawing on this board by following the directions. But it brings in many components of cognition. It brings in visual processing, but also auditory processing, because when you're following directions, you're kind of saying things out loud to yourself. Or you can also do those activities by having a teacher read them out loud to the students. But they often have multi-step sequences within a single direction. So they're having to hold and use their working memory. But it uses a lot of different cognitive processing areas, that one.
All those PDFs are amazing. And if you're listening to this, and you definitely go and try at least one of them. We'll put the links in the description. We're not doing this podcast as a way of selling stuff, but it's definitely really worth looking into some of those. So next one, visual memory. What's that all about?
Visual memory is the ability to remember what one has seen.
Okay.
And that brings in, I suppose, some working memory, if you think about it. No, maybe not, but you might take that visual memory and work with it, and that would turn it into working memory.
Okay.
So yeah, some kids just have a hard time remembering what they've seen. They have a hard time getting it from their immediate to their short-term into their long-term memory. And they just need to practice those skills.
I find that hard to imagine because I rely on my visual memory so much. Isn't that interesting? You just assume that everyone kind of thinks more or less like you, when actually there's lots of different ways where they don't think like you. They think differently. So what does it feel like? What happens when a person has a weaker visual memory? What's happening? How does it feel to them?
That's a great question. So what it is they're not getting visuals. So, well, it depends. If you're trying to recall something that you've already seen, then you have to access an image. And if you have a hard time visualizing, or you don't visualize, we've talked about this before in one of our podcasts, and you have a closed mind's eye or a blind mind's eye, then you really aren't getting any visuals. And so you have to compensate by using your inner voice or your spatials, like your inner spatial skills. But I know that for quite a bit of time in my life, I was not using my visual memory because I had really kind of blocked it. I hadn't used it in so long that I really didn't know how to anymore. And I had to kind of train myself to go back and use it again. I find we've talked about this before, a lot of individuals may have blocked their visual memory because of a trauma. When we have a trauma and we see something really awful, we tend to relive that image over and over and over again. And sometimes if it's really terrible, what our brain does is it kind of shuts down our visual memory so that we can get on with our lives and it just doesn't cripple us. What's better is to get some type of therapeutic intervention so that you can work through that image and replace it with something more pleasant, or not have to constantly relive it. But visual memory is very, very interesting because it really can be blocked.
Wow. So basically that trauma is taking your visual memory hostage, as it were, because it's so closely aligned to it.
Yeah, that can happen.
I've got something else I want to run by you here where, I think of myself as a visual person, okay? And I definitely visually process information. And a lot of people say to me, well, I'm not very visual. I don't see a picture in my mind, okay? And I actually don't see a picture in my mind, although I'm very visual.
What happens for you?
So what I see is the idea of the thing in my mind. So it's not actually.
What is that? Explain that to me.
I've been trying to wrestle with this, right? So if I'm trying to visualize like a turkey, okay, I don't see like a full color picture of the last turkey that I saw. It's kind of more like a line drawing or a faint line drawing that is like archetype of turkey. And so I'm thinking of a turkey, but I don't see it like crystal clear as a picture or anything like that. It's like a very faint, woolly line drawing of it, maybe at best, and often not in much color. But when people see my notes, they're very visual. There's lots of doodles, lots of drawings, lots of colors, and so on. And so in a way, I do quite a lot of my visualization with my pen. It's more black and white, I suppose, although it's not black and white. Does that make sense?
It does. Now, what I would probably suggest is that now, if you did do a very colorful doodle and you just finished it and you looked away, you could probably visualize it quite well. You might actually get some color.
Yes, I would. Yes, that's true. I'm thinking of one right now. Yes.
So you do have the capacity to do that, but you don't necessarily get there unless you've interacted with it. And that's a very specific thing for you. Now, I have some kids that can visualize in such detail that they've said to me, the only reason why that doesn't exist in reality is because it doesn't make a sound. Like I had this one student that just could see things in such that she said, yeah, I can make anything appear right in front of me as if it's a hallucination, which is extraordinary. So I think that there's this massive continuum.
Yes.
But then we are talking specifically about visual memory. And although visualization is tied into it, it's not necessarily the same thing, because you can also have a great visual memory. Maybe you can't visualize, but you can recognize, which is different. So I have a really outstanding visual recognition, but my visualization skills are weaker than my visual recognition. Yes. So they're a little bit different.
Thank you for making that distinction. So, the visual memory is like, I've been in this room before. I remember the shape of it. I remember the layout of it, but I couldn't have described it to you, but I can remember visually that space. That's what you're talking about.
Yeah. Yeah. And it could be anything. I know I personally can remember what people look like if I think of a picture of them more than if I think of them in real life, which is interesting. So it's easier for me to remember the second dimension than the third dimension visually.
Okay.
And I've talked to other people that have been the same, but that doesn't necessarily mean it's that way for you.
Yeah.
So everybody is wildly different. But yes, we all do tend to think that everybody processes the way that we process. And so it's really important to talk about these things, because then we start to realize, my goodness, maybe that has a lot to do with my misunderstandings with people, is because we're processing things quite differently from one another.
Yes. What's next? Visual sequencing?
Yeah. Visual sequencing is the ability to remember the order or series of visual stimuli.
Okay.
So let's think about, it could be a sequence of numbers. It could be a sequence of objects. It could be a visual sequence of steps that you want to follow. You can make it visual. You could also turn it into something that's more auditory. So often sequencing is paired with auditory processing as well, because you might be looking at something. I know that is a strategy that I use, a great compensatory strategy for kids that have a hard time with visual sequencing, is to say it out loud. So if they had to remember, maybe you gave them images of animals and there was a bear, a lion, and a porcupine. They may not be able to remember that sequence, but if they say bear, lion, porcupine, and they say it over and over again using their working memory, that inner voice, that the phonological loop, and they're saying it over and over again, they're supporting their visual memory with an auditory process. But it's interesting, whenever I do any kind of neuropsych testing and I give a test that's looking at, for example, visual memory, because that's also visual memory, right? Mm-hmm. It's looking at visual sequencing or visual memory. I always say, did you use a strategy, or how did you do that? And if they say, oh, I was just saying it out loud in my head, now I'm not really measuring their visual memory or visual sequencing. I'm measuring their visual memory or visual sequencing along with their auditory processing in those two areas, auditory memory and auditory sequencing. So it's really hard to get somebody not to use a strategy. But funnily enough, I find that the vast majority of people that do testing don't ask kids or adults when they're tested whether they used any strategies. And sometimes they're not even aware that they're using a strategy. So you have to say, did you use a strategy? And I might say, do you know what I mean? Did you use anything like your inner voice? But then you have to be careful, because when you say that, then you're suggesting it. And they might use it. So it's complex. It's definitely complex when you're doing testing. And of course, our testing has so many problems to it. And are we really measuring what we think we're measuring? We might be giving a kid a memory task, but what if they lose attention? Then we're really measuring attention. So sometimes a kid will get a very low score on something, and it's important to give them another test that measures the same thing to rule out inattention or fatigue. So now if you're getting consistent scores, then you know that, okay, that's really a deficit area.
You're triangulating it, from different angles. Yes.
But that's really time consuming and really expensive, and not a lot of people do that. So that's visual sequencing. So you can strengthen that area by practicing sequences of numbers, objects, letters, and trying to make them longer and longer, and also talking to kids about developing their visualization skills or their inner voice skills, and teaching them strategies so that they can get better at sequencing or visual memory. But the idea is to make it fun.
Can we play that game? Let's have a little break here from intense dissection of this. And, you do this game where you've got the paper plate, and it relates to this in many ways visually. We've talked about this before, but can you play the paper plate game between us for a few minutes?
Well, and we've played that before when we were talking about visualization, and it really is a visualization and visual memory, but it's interesting because it's all imaginary. Yes. That's right. And you can do the paper plate or the plate game, which I tend to call it, but let's shift it a little bit. Okay. And instead of doing that, because we've done that before in an episode, let's think of it as, let's bring in the visual memory and the visual sequencing, and let's travel somewhere together. Okay. So I'm going to start us off with, imagine that you're in the woods. You're in the deep woods, and you see this hot pink door that goes into this enormous tree, such a big tree. You've never seen a trunk this big. And you go up to the door, you grab the handle, which, by the way, is copper. It kind of contrasts with the pink. It's a little gaudy, right? You grab that, you open up the door. What do you see? What's the next thing that you see? You tell me.
Okay. So I go up to the tree with the big pink door and the copper handle, open it, and I bump into a big porcupine that is sitting on the floor. And it looks up at me and goes, "What are you doing?"
Excellent. So now this is, we're playing this like pass the plate. And for each one of these images, you have to go back to the beginning and rehash it. So, all right. So now I've come back. I'm in the woods. I see this huge tree. I see the pink door with the copper handle. I open it up, and lo and behold, right at my feet, I bump into a porcupine. And he's asking me, what's going on? Was it what's going on or what's up?
What are you doing?
What are you doing? What are you doing? So it's interesting because, now what you've done, we brought in some auditory information too. So now we're measuring not only visual processing, but auditory processing. So then I would add a new thing to the sequence. And I'll say that, okay, I reached into my pocket and pulled out a yellow balloon, which I blew up and balanced on top of his porcupine needles. Now I'm going to pass it back to you.
Okay. I'm in the forest. I see the pink door, open the copper handle, bump into the porcupine. He says, "What are you doing?" I take a yellow balloon from my pocket, blow it up into the shape of a helicopter, and I tie it to the one of the spikes of the porcupine.
Excellent. So basically, this is the concept: is that
Yeah.
you create a visual, you create a story, and you create a sequence that you always start back at the beginning, and you keep adding things to the story.
So there's a visual sequence here. There's visual memory happening here. There's also visual directionality in terms of where things are moving and so on.
Right, you can. And you can bring that in by adding left and right. I had something in my left hand, I had something in my right hand, or in the left visual field, or in the right visual, or below me, or above me.
Or above me, floating above me is the balloon. I was thinking in directionality. So what I find fascinating about this kind of exercise is you're not focusing in on one particular core skill of visual sequencing or visual memory, but you're using a broad spectrum of skills and bringing them together. So if you're weak in one particular area, these other ones are kind of compensating for it as well. And even the storytelling isn't got anything to do with visual memory and so on. That is a whole nother skill set of, stringing along, putting something into the context of a story. So again, another compensatory strategy that gets you to the end result. The test you were talking about the difference between skills, cognitive abilities, and what was the other one? Your actual two types of testing, cognitive testing, and the other type?
Achievement
testing. Okay. So
which is more academic.
So we can find skills to get us towards that achievement, basically. Yeah. Compensatory strategies to get towards that achievement, which really is what we're talking about within this podcast is, that personal brain training is once you start becoming more aware of these things, you start realizing how to get to an achievement that you're aiming for by being more aware of how your brain works, how your executive function works, how your cognition works.
One other thing I want to point out: when you play a game like this, there has to be a very specific sequence. So you don't want to. So one thing that you did is, I said I had a balloon that I blew up and I put on his porcupine needles. You actually slightly changed my visualization.
Yes, I changed.
And now technically what you should do is leave my visualization and then create a new visualization on top of it, so that we are keeping in a specific sequence. I'm glad you did that, because that's really important. And that's something to discriminate between, so that there truly is a sequence of objects or things that happen one after the other. And that's what brings in the sequential processing.
So
and then the other thing is,
so what I could have done is I went into the pocket and I took out a red balloon and I made a yellow helicopter and a red helicopter and stuck it to the top of your yellow balloon. And so
Yes, you
that
could
would
have
be
done that.
building on that. Okay.
Right,
Okay.
right, right. So you always want to be building and not necessarily changing, because that's actually doing something a little different than sequencing. So it all depends
Yes.
on what visual processing thing you're trying to, or area you're trying to strengthen.
Yes.
The other thing is that if you are being specific and you're really trying to pinpoint on visual memory and visual sequencing, leave the auditory component out. So don't have anybody say anything or hear anything necessarily, unless it supports very specifically the visual.
Okay.
So, like, for example, I could have talked about how I took the balloon out, and then when I blew it up, I stretched it and it made a squeaky sound.
Yes.
Right. So then that kind of supports the visual. But if it's somebody saying something, then all of a sudden you're switching from a visual to an auditory, and that can distract the visual. So when you're trying to strengthen a specific area of cognition, you want to keep it in that realm as much as possible. Otherwise, then you're kind of getting the brain to tap into other areas of cognition. And it's best to strengthen an area to focus specifically on that area.
Got it.
So these were all great little things that you brought up. So thank you. The next one is visual closure. And visual closure is the ability to understand images when some parts of the image are missing. So, for example, if you get a poor copy image of a worksheet and parts of the letters are missing, can you figure out what it's saying? Okay. Or say something, you see something in a very foggy atmosphere and parts of it are missing. Can you figure out what it is? It's very interesting because it seems like if you're good at it, you're like, how could that be a problem? But for some
I do that
kids,
all the time. I have to do that all the time.
You have to do what all the time?
That visual closure, because I think part of my dyslexia is that I'm always filling in the gaps. I'm intuitively filling in the gaps. I might miss a word that I'm reading, and so I
that's
backfill.
Auditory closure. That's auditory closure.
I backfill, with logic. But then if I'm reading a very close academic text, it's not always obvious because they're being highly specific with their language. You can't always backfill accurately, fill in the gaps. So I know how that works with visual closure, constantly. I think that's the way my brain works, where I like to fill in the dots, or I always look at an image as if it's always within the context of another image that I can't see anymore, but I'm trying to constantly deduce what context it's in. Does that make sense?
Yeah. So there is visual closure. We'll talk about this in another episode. There is auditory closure. And then there's also reasoning. So you could have excellent reasoning skills to compensate for a poor visual closure. Or you might not have those reasoning skills and really struggle with visual closure. And when you see a letter that's missing a piece of it, you may not be able to tell what it is. But there are those kids that really struggle with visual closure, or adults. It's very interesting. Number 6 is visual reasoning. So you can start to see how a lot of these things overlap, but they're really quite distinct. Yeah. Reasoning is the ability to analyze visual information and find meaning. So you were talking just now in one of your examples, you were talking about, I think, more of the reasoning and the closure. So you're really reasoning with the information to fill in the gaps. Like, what makes sense? What can I compare this to? That's getting more into the reasoning.
There's an exercise that teachers often give children when it comes to their teenage years. It's called a descriptive essay, okay? And they do this in the GCSE, International GCSE, and the British GCSE, which is a 14-year-old, 15-year-old exam for 15-year-olds. And what they do is they give you a picture and they ask you to do a descriptive essay on that picture. And the thing I find so ironic about this is that often children with very high visual processing abilities look at this and get utterly paralyzed with dyslexia, utterly paralyzed. And teachers get confused. They're like, gosh, you're such a visual person. You should be acing this. But what's happening is when they look at the picture, and let's say it's a man walking down the road with buildings to the side, and in the far distance, there's a clock tower, there's some gloomy trees in the corner, and there's a few people in the distance, and this say, write a descriptive essay of this picture. Well, if I'm a visual reasoner, I would say, what, do you want me to talk about it from an architectural point of view? Or do you want me to talk about it from a sociological point of view, the relationship between the people? Do you want me to talk about it like it's a story? Do you want me to talk about it from an environmental perspective? And you just like all these possibilities, like what on earth do you mean by describe this picture? Because your visual reasoning is just going all guns blazing in all sorts of possibilities. And the teacher's saying, well, actually, no, I was hoping you would say there's a man walking down the street with a dog, and there's some gloomy trees, and there's two people in the distance, and there's this clock tower in the very distance. And if you're really very good at this, you would say he's hoping maybe to get to the clock tower on time because there's an important meeting happening there, but he's a little bit scared because the street looks a little bit scared, And the kid goes, oh, is that what you mean? But no one really explains that. But that is visual reasoning on a very basic level, but some of them are reasoning to a much higher level.
Or they might have a hard time with sequencing in general, where they have all these ideas,
yes,
but they don't know how to place them into a sequence.
Oh gosh, yes.
So, there again, there's just so many areas of cognitive processing. You can see how complex it is to get at the heart of what a child's difficulty is. So sometimes you have to, if you don't have the testing, you have to try a few different things out to see where the true problem is. Once you find where the true problem is you want to take them back to an instructional level of where they are and slowly build them up. This just gets really interesting. There's more. Number 7 is visual synthesis. And visual synthesis is the ability to assemble visual parts or pieces into a whole.
Oh, my favorite thing.
So yeah, synthesis puzzles. Can you synthesize all these pieces into a whole puzzle? That's a really good example of visual synthesis.
Okay.
This might be, one of those little puzzles that you do that have a picture, but they could be more of these 3-dimensional puzzles too, which you have to put together as well.
Is visual synthesis basically the archetype of that being a jigsaw? You've got a big picture, and then you see individual little pieces, and you go, I can see where that would go in relation to that big picture, and you're synthesizing. Is that kind of what you're talking about?
Yeah, but and that's one type of visual synthesis, but you're having to synthesize letters into words.
Oh, okay.
So, there are all sorts of things that we visually synthesize and pull together, particularly when you're doing a lot of these games that they have. Think of word searches. Word searches are more probably has some sequencing in there, has some reasoning in there. It may have some synthesis in there. So some of these activities utilize more than one visual processing area. But when I like to strengthen a skill, I like to try to really hone in as specifically as possible to those types of areas of visual processing so that we can really strengthen it. Because otherwise, sometimes we're using compensatory strategies.
Yeah. So basically, you can strengthen it quicker by having more intense practice on that muscle and developing that muscle. Yeah. Got you.
Yeah. So I would say the processing areas are similar to a muscle. It's what is processing? It's not necessarily a physical thing. It's some kind of, well, I guess what it is an electrical thing if we get right down to it.
Yes.
It's an electrical impulse that takes place in our brains.
And we go really back to this metaphor of a manual gearbox to an automatic gearbox. What is processing? Processing is like that difference between a manual gearbox compared to an automatic gearbox. Someone can be very automatic at a particular skill like visual reasoning. Another person can be very slow at that. Doesn't mean they can't do it per se. It just means that they're much more manual, and often, like you're saying, they have to be taken back to first principles and systematically taught how to go through the gears of that process. And I think that sort of metaphor works across every cognitive ability. There are some people who are just automatics at visual memory or visual reasoning, visual synthesis. But when it comes to audio reasoning or audio synthesis, they're much more manual, or maybe written synthesis, written word, etc. They're much more manual, and they have to be taught intentionally to go up those gears.
Well, the interesting thing is that if somebody has a weakness in something, they tend to not like to do it. So they don't practice it very much.
Yes.
Whereas if you're good at it the first time you try it, you like it and you tend to do it more. So many times I find that I work with kids. For example, I can think of a child that I worked with visual spatial deficits, which is our number 8. So let's talk about that. But he had the visual spatial deficits, and he hated doing anything that was visual spatial. And visual spatial is the ability to make sense of visual information in space where the orientation of the objects change or move. So it has somewhat to do with directionality, but not necessarily. He really struggled with that, and he hated doing anything like that, like puzzles, which also can be visual spatial. He didn't like Legos. He didn't like blocks. So he never did any of those things when he was a little kid. So when I worked with him and he was in middle school, I had to go back to really elementary things. And funnily enough, he was older and he's like, oh, well, this isn't as hard as I thought it was, because the last time I tried this, I was really little. And then we slowly kept him in a zone of proximal development and developed that skill because he just didn't have a lot of exposure. And now that we've gone back and we've learned those kind of core skills and we've sequenced the difficulty level, and he got to the point where he started to love the things that he hated because, oh, wow, actually, I can do this. But it's interesting. When you have a strength, you tend to do it a lot more, and it makes it even stronger. And if you have a weakness, you tend to avoid it. So sometimes we just have to go back with these kids when they're older and go back to the things that they're avoiding and build that skill.
Wow.
Yeah, it's pretty cool. So visual spatial is one of my favorites. So that does have to do with puzzles. It does have to do with orientation, but it's more like moving things in space.
So why is that important in life? I mean, I may be asking an obvious thing. I find that natural, but what would be the consequence of having a deficit in this area?
He had a really hard time in school when he was having, because I think in a lot of mathematical concepts, geometry is very, very visual spatial. If you're trying to organize your space, which is getting more into the executive functioning realm, let's go back to working memory. One component of working memory is the visual spatial sketchpad.
Oh.
So some people visualize, but other people, what I call, it's not a real term, but maybe it will become one. Spatialization is, although you're not seeing it, you can kind of feel yourself moving in space. Architecture, you couldn't be an architect without strong visual spatial skills.
I see. Okay. That's interesting that you talked about working memory in terms of, I think of it as the phonological loop and the visual loop, but I've deleted the visual spatial loop. And that's so true. And the thing is, I realize I rely very heavily on the spatial aspect of things.
Yeah, we don't think about it until we think about it. When we really start to think about it, like, oh yeah, I guess I do kind of do that. And you go back to, there was a big study on London taxi drivers. It's extremely difficult. We've talked about this once before. It's extremely difficult to become a London taxi driver because there's no organization to the roads. And in postmortem studies of those that were successful and became London taxi drivers, they discovered that part of the visual spatial part of the brain was overdeveloped in their cognitive makeup than the average person,
Yeah.
which also showed us, really interestingly enough, that cognition can improve at any time within our life. Later on in life, if we really start to hone in on an area, we can strengthen it. And working with that student was such a great example. We did an intensive visual spatial remedial approach. And within 5 months, he went from the 2nd percentile to the 98th percentile.
Wow.
Because we just worked on that one area.
So if you're thinking of him as muscles, he got or he got a 6-pack of visual spatial.
Right?
Yes.
Right. And if you go to the brain and you think, well, memories are myelin sheath, he's actually putting a lot of fat around certain areas of cognitive connections, which is helping him to establish those memories.
Brilliant.
So myelin sheath is made up of all things fat. So it's really important to eat enough healthy fat in your diet, because if you don't, it will impact your ability to remember and to access your memories. So, and our final one, drum roll, visual figure ground. Visual figure ground is the ability to find or detect an image when there are many overlapping images within the visual field.
So it's basically finding Wally.
Yeah, well, as long as there are other things overlapping it.
Do you know what
if you're
I mean
just
by
trying to,
Wally?
We have Finding Waldo in the United States.
Waldo. Yeah. Okay. Waldo. I got it wrong. Waldo. Is that what you mean?
Yeah. Well, that would be visual discrimination.
Oh, I see. Okay. So visual
figure ground is when there are many things overlapping.
Oh, completely over each other, not close by, completely over each other.
Overlapping. So for example, if I had a hand, like think of drawn images, like we'll go back to your turkey and a hand and maybe a dog and maybe a tree, and all of those were overlapping.
Yes.
Could you discriminate what 4 objects were there?
Oh, I see. Okay, I've got you. Right.
So yeah, I guess it's something that doesn't, trying to think of some examples of where that happens in real life. But it's interesting when people have a really hard time with visual figure ground, it can have an impact on processing with areas of academics.
So basically all 9 of them are basically visual processing difficulties.
They are all visual processing difficulties. And there are other areas that I want to talk with you next week that have to do with visual processing, like processing speed or visual scanning and tracking and visual motor integration and peripheral vision. Those are all related, but they're not actually visual processing. So we are just sticking very specifically this week to areas of visual processing.
Erica, that has been amazing. What a tour de force of explaining that so patiently to us. I just love these conversations where we go in depth into these areas and start applying them to real life and so forth. Thank you very much for this.
And I love the fact that there are times where we dip into things that you don't know a lot about because you ask the right questions that I might skip over.
I think with this one, like I am so strong on my visuals, that my weaknesses tend to lie within the words and grammar and English and so on with dyslexia, that I compensate by using the visual side of things. I think I'm on the 99th centile on most of these things when I did my test.
And I'm so glad you brought that up, because both you and I have dyslexia. Yeah. And if you don't know that already, we've mentioned that in past podcasts, but what's most important to understand with dyslexia is no 2 people have the same type of dyslexia. As you can see, there are 9 different types of visual processing. Yeah. There are just as many different types of auditory processing. Yeah. And there are other aspects that can lead to a dyslexia diagnosis. So you can have a type of visual dyslexia. You can have a type of auditory dyslexia. You can have a visual / auditory type of dyslexia. And then there are other things like word finding issues can lead to a diagnosis of dyslexia. So there's so many different ingredients that can make up dyslexia, and understand that each individual kid has their own ingredients within these realms that can lead to that diagnosis. And it's important to dig through and look through at their testing and do testing if necessary to figure out what are those areas for them that are tripping them up, and then go in and do that work to strengthen those weak areas of cognition. And then some magical things start to happen.
You can also flip it the other way around to say,
Yeah.
I don't have problems with visual discrimination or direction. Well, I've got maybe some directionality difficulties visual, but it's one of these things where you think, what, people have a problem with visual closure or visual reasoning or visual synthesis or, visual figure grounding. It's like, doesn't everyone manage that? And then you realize someone beside you goes, no, I find that really hard. You realize we all have strengths and weaknesses, and we need to play to our strengths in order to compensate for our weaknesses. And I think that's, well, my own philosophy is, I know your philosophy is often to go in and strengthen a weakness, and I agree, but I tend to come from an ethos where try and find a strength and double down on that strength and use it in some way to achieve the same outcome as the weakness requires. And often you see that in MRI scans of people with dyslexia, when they fire up, and you see that region of the brain that is involved in decoding words, it's often lower heat on the map, but then other areas of the creative side of the brain are lighting up if they can do the task. And you can see that they're compensating with other parts of the brains. You can even see it in MRI. So I think there's a natural predisposition of our brains to do that.
Yeah, the brain can definitely use other areas of cognition to compensate. But I do think that my philosophy is actually a combination of the two. You want to strengthen areas that are tripping you up, and you also want to develop your strengths. So doing a combination of both, because you don't want to necessarily hobble through life with this weakness. And for many kids and adults with dyslexia, it becomes terribly embarrassing, or like dysgraphia. You don't have to have terrible handwriting for the rest of your life. There are ways to develop that skill. And then you can kind of let go of that feeling of shame. So I think it's a really combination of going back and strengthening some of those skills. And some kids have such a disability that we may never be able to get them up to an average score, but we can get them up to a certain point.
And something I've learned from you is that you once told me that there are some children who are very visual, but when they come to you, they're spending so much of their cognitive load on the processing of words and so on that they don't have the energy to concentrate on their actual ability, which is often the more visual side. So actually, and it really won me over, that argument that coming to a place of automaticity on some of these lower level skills, that we're having to spend so much cognitive load to do manually, but bringing it up to a point where you're automatic, it releases a lot of cognitive load for the things you are good at. And I think that's a very convincing argument for taking the time to actually strengthen some of these weaknesses that are core to just day-to-day functioning, so you release some of that cognitive load for better stuff.
Yeah. What it really boils down to is you want to go back and strengthen some areas of weakness, or as many as you can that's comfortable to a certain level. And if the kids are enjoying it, continue to take them to higher levels. But also, the compensatory strategies are huge. Learning things like memory strategies, yes. Learning all sorts of strategies that can enable them to use strengths to compensate for some areas of weakness too is important, just so that people really can manage their cognition in ways that help them to achieve their goals.
And on the final note, then, I would ask our podcast listeners, what happened after the pink door? I bet you can remember what happened after the pink door because you learned some memory compensatory strategies from Erica here. Thank you very much, Erica. See you next week.
Bye.
Bye, guys.
Thank you for joining our conversation here at the Personal Brain Trainer Podcast. This is Dr. Erica Warren.
And this is Darius Nomderon. You can check out our show notes for links to resources mentioned in the podcast. And please leave us a review and share us on social media. Just take a screenshot and post it up on your social. And until next time, see ya.